Okay, so let's start with the next set of topics. So the four presented on your screen are the advanced integration techniques. So probably I say it as advanced since these techniques um, only happens when you have special types of integrals. So for example, what we have discussed so far, so you are just given the formula. So if it follows the formula, then you directly use the formula. But what if it doesn't follow the formula? So these are where the steps come in, these four steps. Okay, so we will be discussing each step by each meeting. So we'll be finishing by the whole advanced steps on next Thursday. So also be mindful that the midterm exam is scheduled on the 26th of March. So that would be on Saturday. And it would be from 1:30, I think, to 4:30 p.m. So this is what has been discussed by the EM coordinator along with other EM teachers. So the coverage was cut short up until this topic, up until the advanced techniques only. So if you try to look up the syllabus, the definite integral was opted out in the exam since most of the teachers weren't able to reach that portion due to the effects of the typhoon. So some, like me, have been delayed with the discussion due to the internet connection problem. So others have electricity problems before they even started having classes. Okay, so try to be mindful of this date. And of course, as we try to discuss along with the different techniques, so I think take the assignment as part of your review for the midterm exam. All right. So let's start off by discussing first algebraic substitution. So algebraic substitution is probably just like the U sub. So if you try to read this phrase here, introducing a new variable of integration in place of the original variable. Diba? So mura siya U sub gyapon, but we're not using U sub as of the moment since U sub will still be in use on the other parts of the algebraic substitution. So it may be used, it may not be used as long as um, think of algebraic substitution as an advanced U sub technique lang siguro. Yan na siya. Okay, so again, the substitution method is has no techniques, no general rules. It only comes with practice. So of course, it comes with the inspection of the integrand, same as the U sub. And again, it's more likely of a trial and error method. But probably my only rule here in algebraic substitution is you replace the radical expression. So what do you mean by radical expressions? Those having root functions, square root, cube root, etc., so on and so forth. Okay, so with this, let's try to solve 7 examples. So notice that each example have different different radical expressions, diba? Square root of x, square root of x, square root of x minus 4, fifth root of x plus 1 squared, cube root of x plus 1, cube root of x squared plus 4, square root of x, and cube root of x. So notice that all of the examples have radical expressions. So most likely, algebraic substitution is more inclined to the replacement of radical expressions compared with any other substitution technique. So also you may try to use algebraic substitution in non-radical expressions, but probably a better way to do it is through other methods, not siguro algebraic substitution. Okay, so let's try the first example. So usually when we try to use algebraic substitution instead of using u sub, diba? So algebraic substitution is now called the z sub, or you use the z parameter to replace the replace the radical expression. So z is equal to square root of x. So again, we're not interested in um, getting the derivative directly. So after determining that z is the radical expression, we try to eliminate the radical symbol by squaring both sides. So this becomes z squared is equal to x. All right. And then this time we now derive each side, or take the derivative of both sides. So this becomes 2z dz is equal to dx. Okay, so notice that square root of x, dx, and the x variable can be replaced in the given equation. So square root of x becomes the z parameter, dx becomes 2z dz, and then x variable becomes z squared. So upon replacement or substitution, so we have z, then dx is 2z dz divided by 1 plus z squared. So of course we can try to take the constant outside, which is 2. So this becomes 2. Then multiply the z in the numerator. This becomes z squared and dz all over 1 plus z squared. So if we try to look at the given fraction, the degree in the numerator is the same as the degree in the denominator. So what I mean by degree, that's the exponent. The highest degree, the highest exponent is squared. So if the numerator is greater or equal, or if the numerator, the degree of the numerator is greater or equal to the degree in the denominator, so you may use long division. Long division. So of course, the long division technique is used to simplify your equation. So I hope you still remember how to do long division. So this will be the divisor divided by the dividend. Okay, so 1 multiplied to this one, diba? So this will be z squared plus 1, then it's minus, diba? So we have here negative 1. So for you to write the answer, that would be the quotient minus the remainder over the divisor. So that's how we write our new equation, diba? So getting the new equation now is that we're going to have it as 2 integral of 1 minus 1 over 1 plus z squared dz. So if you want to separate the two integrals, you may do so, but at least you know how to differentiate, or you know how to gauge the level of difficulty for each term of your integral. So 2 integral of 1 over 1 plus z squared dz. So for the first integral, is that it can easily be integrated, diba? Which gives us z. So how about the second integral? So saan na siya ron pag 1. So as you may notice, the second integral is actually a basic formula, which is inverse trigonometric formula. So try to recall this format, which is du all over a squared plus u squared. Diba? A squared, u squared. So it gives the arctangent function or the inverse arctangent. So meaning the answer would be 2z minus 2 arctangent z plus c. So of course there's no more 1 over a because a is just 1. So 1 divided by 1 would give us 1, and writing 1 is not really practical in mathematical terms, di ba? Usually opt 1 or emit 1, murag invisible 1 lang siya, di ba? Ang dating niya. So don't forget to bring back the value of the z parameter, which is square root of x. So our final answer would be 2 square root of x minus 2 arctangent square root of x plus c. So this would be the final answer. Okay. So any questions for example number 1? Hello? Okay, so there's no question. So simple pa siya, di ba? So let's try another problem. So again, our aim here is to replace the radical expression. So starting off again with z. So probably once we go through the different examples later on, um, the process is repetitive. So marag maboringan siguro mo. Okay, you always start with z, and then this should be equal to square root of x. Okay, so eliminating the radical expression by squaring both sides. So this gives us z squared is equal to x. And then getting the derivative of both sides. So z squared, 2z. Z squared becomes 2z dz. And then dx. So again, we can replace dx. We can replace x variable. We can replace square root of x. So dx becomes 2z dz, square root of x becomes z, x becomes z squared. So of course in actual examination, so I'm not requiring you to put some lines in the solution. So akong lines there is just for the sake of discussion, so that you may be guided once, especially once you try to view the recording again, diba? So you're going to have in the numerator that would be now 2z dz. Then denominator would give us z squared minus z. So taking out the radical expression, and we can try to factor out 1z in the denominator. So this would give us 2z dz all over z times z minus 1. So we can cancel out 1z here, and this would give us 2 integral of dz all over z minus 1. So again, notice that you have dz over z minus 1. So if you want to verify that it's really ln, so you may use u sub, di ba? So z minus 1, and then getting the derivative du is equal to dz. So dz is now du, and then z minus 1 is now u parameter. So di ba, that's the purpose also of having another variable in the substitution method, because one is z and then the other is u, di ba? Bali, dili siya magbangga, dili magbalik-balik inyong variables. The variables will not be recurring, di ba? It's another type of variable that you are presenting in the equation. Okay, so this would give us 2 integral of du over u. And then by basic formula, this would give us 2 ln of u plus c. So again, bring back the value of the u parameter, which is z minus 1. And then lastly, sorry. And lastly is bring back the value of the z parameter, which is square root of x plus c. So this would be the final answer. All right. So questions or clarifications for this example? Okay, so hearing none, let's proceed with the next example. So this time is we're going to have the integral of x cubed. So take note that the cube is on the x variable, not the index of the radical expression. So x cubed times the square root of x minus 4 dx. So again, starting off by declaring the radical expression as z. So x minus 4, then taking the square of both sides to eliminate the radical expression, this would give us z squared is equal to x minus 4. Then taking the derivative, you're going to have 2z dz is equal to dx. So derivative of negative 4 is 0 since it's a constant. Okay, question? Wala question? Dili mahimong? Dili. Kay kuha man ni siya. This one in exponential format, this would give us x minus 4 raised to the power of 1/2. So meaning if you try to square everything, diba, squared, so kani siya ma-cancel out, diba? So what remains is x minus 4. And then the other one would be squared, diba? Z squared. So apil siya sa tibok balay-balay, diba? Sige, question? Sakto. Okay, it should be, kuha mo na siya. It should be dx minus 0. But of course, para dili kay siya repetitive, magsige mo swat og 0 and then eliminating it afterwards. So you may just write it as dx. Okay? So try to remember that in ika-square niyo sa inyong root function, dili ma-affected ang sa under sa roof ana. Just try to imagine that what's under the roof cannot be affected once you eliminate the radical expression. So for example, you eliminate the radical expression, square root, so x minus 4 will still remain as x minus 4. So it won't be doubled or tripled depending on the degree that you are multiplying it, or let's say the power that you are applying to it. So gets ra gets. Okay, so sige. Okay, so let's proceed to the next step. So try to also, again, kanina is atong itong declare, diba? So dx can be replaced because we have 2z dz. Square root of x minus 4 can be replaced, having it as z parameter. For x cubed, so we try to replace it as x lang. So where do we get this x variable? So we get it in this, sorry. So we try to get it here sa kaninga equation. So isolate x parameter, x equals z squared plus 4. So again, if we try to track down the substitution method, so dx is going here, and then square root of x going to the z parameter, x variable is going to this one. Now for you to be guided. So x cubed first, so you have z squared plus 4, and then cube, and then square root of x minus 4, that's z, and then dx is 2z dz. So we need to try to simplify first the equation before we try to integrate. So removing the constant, this would give us z squared plus 4 cube, and then on the outside of it is z squared dz. So z squared, z squared. All right, so before we can multiply z squared to this whole term here, is that we need to expand z squared plus 4 cubed, diba? That's the correct way of doing it in algebra. So I hope you still remember your algebra on how to expand binomials to the third degree. So if you don't recall, so try to recall Pascal's triangle. Diba usually atong naibawan jud sa ato ang algebra before is kato man yung a squared plus 2ab plus b squared. So it's coming from Pascal's triangle gyapon. So Pascal's triangle. So one is descending order, the other term is ascending order. So 1, 2, 1, di ba? 1, 3, 3, 1. So most likely this is the popular equation, which is, so again, Pascal's triangle is a plus b raised to the power of n. So the first one is 0, the second line is the first degree, the third line is second degree. So if it's to the power of 2, so meaning kuha na siya, squared na siya, di ba? So I think the third line is the popular formula, a squared plus 2ab plus b squared. Diba? That's the very popular formula. So also notice that the first term is decreasing in order, a squared, a, then a to the power of 0 on the last term. For b, it's increasing order. In the first term, there's no b because it's b to the power of 0, which is equal to 1. Second term is b to the power of 1. Last term is b squared. So if you try to analyze the third line, if it's to the power of 3, so it will give us a cubed. So again, there's no b, plus the coefficient, again 3. So again, the 2 here was presented in the middle term. So of course, the number of terms here will also represent, rather the number of um, coefficients presented will also represent the number of terms. So you have 1, 3, 3, 1, so meaning you're going to have 4 terms. So sa second degree, you only have 3 terms, 1, 2, 1. So that's why a squared plus 2ab plus b squared, only 3 terms. So here is a 3, so again, descending order, 3a squared. Then the b starts coming out because it's increasing order, plus 3ab squared. And lastly is b cubed. Okay, so in our case, our a squared is, or rather our a parameter is equal to z squared. Our b parameter is equal to 4. So if we're going to apply this one, so this would give us z squared cube, okay, 3 times z squared squared times 4 plus 3 times z squared and then 4 squared. Then lastly would be 4 cubed. So the equation would give us z to the power of 6 plus 3 times 4, that would be 12, z to the power of 4 plus 16 times 3, that would be 48 z squared. And lastly, 4 cubed is 64. Okay, so this is what will come out in the next line. So 2 integral of z to the power of 6 plus 12 z to the power of 4 plus 48 z squared plus 64 and then z squared dz. So this is the time that you can now multiply z squared to each term in the parentheses, inside the parentheses rather. Okay, so this becomes z to the power of 8 plus 12 z to the power of 6 plus 48 z to the power of 4 plus 64 z squared dz. All right. So probably at this time, we can now say that we can integrate manually each term. So we can say that the first one would be 2. So don't forget to multiply 2, okay? It's on the outside of the integral symbol. 2 times z to the power of 9 over 9 plus 2 times 12, that would give us 24 times z to the power of 7 all over 7 plus 48 times 2, that would give us 96, and then z to the 5th power all over 5, and then lastly would give us 128. So 64 times 2 is 128, and then z cubed all over 3 plus c. All right. So I think this is the final answer, but you just have to bring back the value of the z parameter. So take note that since you are dealing with radical expressions, then Napojo exponent sa answer, diba, to the power of 9, and then you're dealing with 1/2. So just try to multiply 1/2 and 9 upon replacement of the variable z. So the final answer would look like this one, 2 times x minus 4. So 1/2 times 9, that would give us 9 over 2 all over 9. Then plus 24 x minus 4. So this will give us 7 halves over 7 plus 96 times x minus 4. Then this will give us 5 halves over 5. Then lastly is 128. So I'm trying to fit in everything na lang siguro kaya maglisod the space. X minus 4 raised to 3 halves all over 3 plus c. So this is your final answer. All right. So questions for this item? So I think there's no question. So let's proceed with the next example. So number 4 is the integral of x times the fifth root of x plus 1 squared dx. So again, our declaration for the z variable is the radical expression. So fifth root of x plus 1 squared. So again, you may write it in exponential format for you not to be confused. So this would give us x plus 1, and this would now be 2/5. So it's 2/5 because you have squared, that would be the numerator. The index of the radical expression will be the denominator. So again, multiplying by 5 over 2. So of course, you multiply it by 5 over 2 for us to eliminate the radical expression. So this would give us z to the power of 5 over 2 is equal to x plus 1. Then taking the derivative, so bring down the exponent, 5 halves, z, 5 halves minus 1 would give us 3 halves, dz. Then the right side would be dx. So I hope by now that you have mastered your fractions, adding and subtracting fractions with whole numbers. So para mas madali inyong kinabuhi, di ba? So we have dx, we can replace dx, we can replace the fifth root of x plus 1 squared. For x variable, we can manipulate this term here. This gives us x equals z to the power of 5 halves minus 1. All right. So again, dx is this term here. Fifth root becomes the z parameter. The x parameter becomes this one here, z to the 5 halves minus 1. Okay, so writing the new expression, this would give us z 5 halves minus 1 times z, and then 5 halves z to the 3 halves dz. All right. So we can try to factor out the fraction or the constant, which is 5 halves. And this would leave us with z to the power of 5 halves minus 1, and then z, and then z to the power of 3 halves dz. Okay, so multiply each term, then multiply with the second term. Okay, so for this one, we're going to have 5 halves. Then for the first term, it is now z to the power of 5. Shocked na eh, di ba? Yun sa pag z to the power of 5. So always remember that the middle term here is z to the power of 1. So again, multiplying exponents having the same base, meaning you just have to add up the exponent. So 5 halves plus 1 plus 3 halves would give you 10 over 2, thus leading you with 5. The next term would give you minus z to the power of 5 halves. So ano 5 halves man sir? So just try to do your fractions. Ano 5 halves yeah. So 1 plus 3 halves is 5 halves. TZ. Alright, so I think now you probably can integrate this one. So again, don't forget to um, multiply with the constant that was taken outside the equation. So the first term is 5 halves. Then this would give us z to the power of 6 all over 6. And then minus 5 halves times z to the power of 7 halves all over 7 halves plus c. So cancel out 2, cancel out 2. So if you ask me why it's being canceled out, so try to divide it using your calculator or try dividing it using basic terms. So probably if you try to recall dividing fractions, a divided by b, a over b divided by c over d, this would give you ab times d over c. Diba? Maragana siya nga concept. So just try to recall how to multiply or divide fractions. So this would give us to 5 over 12 z to the power of 6 and then minus 5 over 7 z to the power of 7 halves plus c. Alright, so again, don't forget to bring back the value of the z parameter. So take note that the exponent is 2/5. So 2/5 times 6, this would give us 5/12, 5 over 12, and then x plus 1. Then this would give us 12 over 5 minus 5 over 7 x plus 1. So again, 7 halves times 2/5 would give you 7/5 plus c. So this is the final answer. So questions for example number 4. So probably what's the problem after declaring the z parameter is that I think the problem is purely algebra. So the expansion of the binomials, the multiplication of powers having fractions, and I think what you will be having difficulty in later on will be the fractions. Okay, most of the time in my experience, most of my students magkalisos like fractions. So I don't know why. Okay, so no questions for example number 4. So let's proceed with the fifth example. Oh, so another question. Gawas na yun ng question. Sige, what's the question? Excuse me, wala ko dong og hello. Kinsa man to ni raise line. So over 5, it's 6, kanisha 6, multiplied by 2/5. Ya, kaning sa 7/2 multiplied by 2/5 muna. Makancel out man 2, so muna 7/5 ya. Okay? So any other question? Murag, it's too loud. Wow ka kuan kayo. Unsa to inyong question? Nga naman. Okay. Okay. Sige, sige. Okay, so let's proceed with the fifth example. So again, you're going to replace the radical expression. So that's the cube root of x plus 1. So again, getting the cube root, rather the cube of the whole expression, this would give us z cube, and then this one is just now x plus 1. So getting the derivative of both sides, so this would give us 3z squared dz is equal to dx. So again, we can replace this one with z. We can replace this one with 3z squared. So how about for x? So we try to isolate x using this expression here. So x equals z cubed minus 1. So again, this one is z. This one is dx. This one is x for example. So the equation becomes, in the numerator, first is it's z cubed minus 1. Then dx is now 3z squared dz. The denominator is just the z parameter. So cancel out the z in the denominator, cancel out 1z in the numerator. So this would give us a simpler format of z cubed minus 1 times 3z dz. So again, we can multiply z inside the expression and take out the constant outside, 3, and then this becomes z to the power 4 minus z dz. So again, we can now integrate easily with this function. So you now have it as 3 times z to the power of 5 over 5 minus 3 times z squared all over 2 plus c. So we're going to have 3/5 z to the power of 5 minus 3/2 z to the power of 2 plus c. So again, if you try to convert this one into its exponential format, x plus 1 raised to the power of 1/3. So 1/3 multiplied by 5 multiplied by 2. So our final answer would be 3/5 times x plus 1 raised to 5/3, then minus 3/2 x plus 1 raised to 2/3 plus c. So usually you can verify your answer if it's correct if the denominator and the numerator of the exponent is the same, di ba? 5, 5, 2, 2. Ano? Most likely, inana ang pattern sa inyong mga answers if sakto siya. Okay, so questions for number 5. Okay, so there's no question, so let's proceed with number 6. So again, we try to replace this one with z. So it's cube root of x squared plus 4. So getting the cube of both sides, this would give us z cubed is equal to x squared plus 4. And then getting the derivative, this would give us 3z squared dz equals 2x dx. So plus 0, so that would be the derivative of 4. So as you can see here, our dx has an x variable, di ba? So probably if we try to rearrange this one, this would become 3 halves z squared dz and then x dx. So looking at the expression, we have x cubed in the numerator, di ba? But we have x only in the derivative sa ubos, x dx. So how are we going to do that? So let's try breaking this one down into its components. So instead of x cubed, let's try x squared times x, di ba? So we now have x dx, di ba? We also have a cube root of x squared plus 4 as z. So how about x squared? So x squared, so notice that here we can try to rearrange this one as x squared equals z cubed minus 4. So meaning we can declare everything in the expression. So again, for you not to be confused, x cubed becomes x squared times x. X squared can be replaced, x dx can be replaced, and then this one can be replaced as the z parameter. So ano na siya, usually you need to manipulate your expressions so that you can see whether you're able to use the algebraic substitution or not. Di ba? There's no general rule, but it only requires practice. So probably that's the purpose also of having the assignment. So 10 problems per topic. Okay, so we're now going to replace or substitute the different variables. So x squared now is z cubed minus 4. And then x dx is 3 halves z squared dz. Then divided by z parameter. So again, cancel out 1z, cancel out this 1z. So you don't cancel on the first term, okay? It's a binomial. So you only cancel factor to factor. Okay, so taking 3 halves outside since it's a constant. So 3 halves integral of z cubed minus 4 and then times z dz. So further expanding by multiplying z. So you have 3 halves integral of z to the fourth minus 4z dz. So you can now integrate. So 3 halves. So again, don't forget to multiply 3 halves to each term upon integration. So 3 halves times z to the fifth all over 5 minus 3 halves times 4 times z squared all over 2 plus c. So cancel out 2, then cancel out another 2. So final answer would be 3 halves z, or rather it's now 3 over 10, 3 tenths z to the power of 5 minus 3 z squared plus c. So if you try to bring back the value of the z parameter, so again, in exponential format, this would be x squared plus 4 raised to 1/3. So 1/3 multiplied by 5 multiplied by 2. All right, so we have 3 tenths, then x squared plus 4 5/3, diba? Minus 3 times x squared plus 4 raised to 2/3 plus c. So this would be the final answer. Okay. So questions for number 6. Okay, so no question. So let's move on to the last example. So you have here the integral of 1 over square root of x plus cube root of x dx. So notice that we cannot declare directly or immediately the z parameter since you have two different radical expressions. So if you have two different radical expressions, what you need to do here is you're going to create another radical expressions wherein if you declare that particular radical expression as your z, it will eliminate both radical expressions in one go. So ang pasabot is in Bisaya, ita kag lain na term nga maka-represent sa both radical expressions para inika later on ma-eliminate siya dungan. Diba? Mawala ang radical expressions og dungan. Okay? So to do this, probably the most shortcut way to do this is if this one is x to the power of 1/2 and this one is x to the power of 1/3. So the easiest way to do is just multiply the exponents. And you're going to have x to the power of 1/6. This will be your z parameter. So that's the shortcut. That will be the most shortcut way to do it. So this would give us z is equal to x to the power of 1/6. So multiplying by 6th degree, z to the power of 6 is equal to x. And this would give us 6z5 dz is equal to dx. So probably you may say that we cannot replace square root of x because it's not totally the z parameter, but however, we can replace it with the x parameter. And by replacing with the x parameter, we can eliminate both radical expressions. So meaning Instead of replacing the whole square root of x and the whole cube root of x, here in this problem, we just replace it with this term here. And also the dx. So if we're going to apply it now, so this will give us 1 all over the square root of z to the power of 6 plus the cube root of z to the power of 6, and then dx is 6 z to the power of 5 dz. So notice that the square root of z to the power of 6 is equal to z cubed, di ba? The cube root of z to the power of 6 is z squared. So meaning this would give us, so let's try to multiply this to the numerator. So this would give us 6z5 dz all over z cubed plus z squared. So trying to factor out 6, then trying to factor out z squared in the denominator, this would give us z to the power of 5 dz all over z squared times z plus 1. So eliminating two z's, the numerator becomes z cubed. So you now have 6 integral of z cubed dz all over z plus 1. Again, as I mentioned earlier probably in the first or second example, if the numerator has a greater degree or equal degree with the denominator, you may use long division. So here, using long division, you can have it as z plus 1 divided by z cubed. So you have it as z squared first, and then z cubed plus z squared, then minus. So next is z squared. So that would be plus z squared plus z, and then minus the pod, then minus z, then this one is minus 1. And this would give you negative z minus 1. So the remainder is 1. So the new fraction would be, the new expression would be z squared plus z minus 1 and then plus 1 over z plus 1. So since there's no more space, so just try to continue this line here with the integration process. So any questions or clarifications regarding this topic? So to summarize, probably again, the end of this, the overall or the totality of this technique is just to eliminate radical expressions. So not really totally eliminating it, but rather you have to substitute it with another variable to make the expressions more easy to look at. Rather than dealing with radicals itself, so you're dealing with simple variables that you can handle with ease, rather than looking at some roots that will give you some headache nga basta niya mag-give up na lang mo answer, di ba? All right, so I think if you don't have any further questions, so see you all on Thursday for our next topic, which is about trigonometric substitution.